Okay, Math 9, so here we go with our exponents. Welcome to the wonderful world of them. Now we've seen them a little bit briefly with BEDMAS, but we're gonna look at them a little bit closer now in the next few sections. Exponents are not overly challenging, but there are some minor details they're gonna throw us for curveballs that we really wanna focus on. So here we go. First thing to do is, what are exponents? Well, we saw them, like I said, we saw them in BEDMAS. Exponents are the little numbers up above either letters, variables, right? And we're not really going to see much of this year, but we will see some, but mostly we'll see this, okay? It's the little number up above the whole number. Okay, those are what we call exponents, or sometimes we call them powers. Powers, exponents, that's what they are. Now, what do they mean? Exponents are repeated multiplication. So when we first started learning addition, we would go 5 plus 5 plus 5, but there had to be a shortcut to that, and it turned out there was. That means 4 times 5. So it turns out that the short version of repeated addition, so short repeated addition, is multiplication. Instead of just adding over and over and over again, we multiply. Well, what happens if we multiply over and over again? That is what exponents give us. They give us a shorthand of repeated multiplication. And this means 1, 2, 3, 4 of them. So it's 5 to the power of 4. It means repeated multiplication. So if you have, I'm just going to erase the left side here. If you have anything to a power, it means it's that thing times itself. So if you have 2 to the power of 4, that means we have 2 times 2 times 2 times 2, 4 times. If we have 7 to the power of 3, it's 7 times 7 times 7. Exponents are repeated multiplication. Now, negatives matter. Negatives in what's called our base, right? This is our base, this is our exponent. The number that is being raised to the power is what we call the base. You're going to hear me say common base a lot coming up here. So brackets actually do matter, because here we have -2 is my base in brackets, and it's times itself twice. Here we have -2 in brackets times itself 3 times. Next slide, you're going to see why this makes such a big difference. But now here we do not have brackets, and this is an incredibly important distinction to make. The negative out front is not part of the exponent. It just means -1 times 2 squared. So it means -1 times 2 times 2. In this case, it means -1, 2 times 2 times 2. You're going to see why that is such a huge difference later. So the brackets really matter. If there's no brackets around it, the negative is not included with the exponent, because that's going to change things into what we call forever positive and forever negative. And as I showed here, this is -2 times -2, which gives you a negative times a negative is a positive number. So if you have a negative in brackets to an even power, 2, 4, 6, 8, 10, any of those, the answer is always going to be positive. It is going to be forever positive, which means we could write this as this, because they have the same value in the end. Now we'll come back to this in a minute, because first we want to look at these two here. Okay, as I said, that's a -1 and then times 2 times 2, and this is a -1 and then times 2 times 2 times 2. So the negatives aren't repeated, so the exponent has no bearing on whether or not it's positive or negative. But what happens is the answer is always negative. Here we get -4, here we get -8. So these scenarios, when a number looks like this or looks like this with no brackets, these are what we call forever negative. And it just means you have a -1 out front of the statement. So that brings us to this one right here. This one is -2 times -2 times -2. And if you multiply a negative number an odd amount of times, you're going to end up with a negative number. So this is what we call forever. That's not an F. This is what we call forever negative, which means anytime you have a negative base in brackets to an odd exponent, So 3, 1, 5, right? It will be forever negative, and we can write it like that, which means we can write it with that negative far removed. So this is going to come in handy when we get into a base that looks common but isn't common. So let's look just a little bit closer now. We'll look a little bit closer in our next section, section 2.2. So let's look here at, okay, well, we've dealt with the idea of repeated multiplication, and we've looked at negative signs and how they affect things. What about determining a power? When you get into grade 12, you learn about these things called logarithms. Don't freak out, logarithms are great, but they allow us to solve these type of questions in a simpler way, but they're a little bit more confusing at your current level. So what helps is to look at the fact that you know that 64 is 2 to the power of something. We just don't know what. So take your 64 and break it down into factors. Well, 64 is 2 times 32, which is 2 times 16, which is 4 times 4, but 4 is 2 times 2, 2 times 2. And we would expect to see this because we know 64 is 2 to the power of something, and look at that, every single factor is a 2. 1, 2, 3, 4, 5, 6 of them. So 64 is equal to 2 to the power of 6. So if you're given a kickoff point, like 64 is to 2 to the power of what, you know to divide it all the way down to 2's. If we look at 243, well, it's 3 to the power of what? Well, that should just be a little bit of a teaser that you know you're going to be dividing it by 3. 3 goes into 24 8 times, no remainder. 3 goes into 3 once. That's 9 times 9, which is 3 times 3, 3 times 3. 1, 2, 3, 4, 5, which means 243 is 3 to the power of 5. So that's how you can solve those without understanding logarithms. It's just about repeated division down to the base that we are looking for. So that is the most basic concept behind exponents, but this whole section is going to grow one on the other, on the other, on the other, on the other. So make sure you got this concept of forever positive, forever negative locked down when you see brackets and no brackets, but have negative bases. Thanks so much. See you next time.